In our last video on transfer learning, we used pre-trained model directly as a classifier to classify new input images. And we have seen that with the example of a pre-trained VGG16 model, which was given an image of a frog. The second pattern in which you can use these pre-trained models are as feature extractors. So in this example, we will use the pre-trained VGG16 model as a standalone program to extract features from a given image. These extracted features from an image will be a vector of numbers that our model will use to describe the specific features in that particular image. These features can then be used as input in the development of other new models. So to get started with, we have the same code from before. So in the first half of the code, like in my previous example, I am loading my image and as well as preparing my image so that it could be fed into my VGG16 pre-trained model. And then of course I am loading my VGG16 model directly from the Keras library. Now we already know how a VGG16 architecture looks like. So as you can see, before its output layer, it has a fully connected layer which has 4096 neurons. So as like any convolutional neural architecture, we know that VGG16 also have two parts to it. One is the hidden layers and the second one which is the actual classification layers, right? And so before my output, which has 1000 neurons, we have a fully connected network of 4096 neurons. So what I am doing is I don't want my final output layer, that is, I don't want that final output layer with 1000 neurons, but instead I need the second last layer, which is my layer with 4096 neuron. So I wanted to obtain all the features which is extracted until this 4096 neuron layers. So for that, of course, I will have to remove my output layer from my VGG16 model. And that is exactly what is being done in this layer. I am removing my final output layer in my VGG16 model, and I am instead making the second last layer, that is the fully connected neural network with 4096 neuron, to be my new output layer. And then I am asking it to print the shape of what is the shape of my extracted feature, and then I am dumping all these the extracted feature from my image into a pickle file named frog.pickle. So let us go ahead and run this example and see what is the result. So running our code will load the image and then prepare the model as a feature extraction model. The features are then extracted from the image I have provided, and the shape of the feature vector is printed. So what you see here is actually the shape of my feature vector. That is, I have 4096 numbers which are a representation of the features that is being extracted from the image that I have provided. And of course, these feature vectors will be saved in a new file called as frog.pickle in my current working directory. So if you look in my current working directory, I have the extracted feature in my file called frog.pickle, and the image I had actually given was this frog image. So all the features from this image is now extracted and stored in a file called frog.pickle, and we have 4096 features that is been extracted. So this is how I can use my pre-trained model as a standalone feature extractor, and in this case I have extracted the features from an image which was actually a frog, image of a frog. Let us now look at using pre-trained model as feature extractors, but in a slightly different scenario. Now, it is always possible that we can add new layers on a predefined model. For example, this is our VGG 16 architecture, and as we know, until this point from here to here is the actual feature extraction part, where we have set of convolution and pooling operation performed. Whereas from this portion to the end, the output layer is where the actual classification happens. So we have fully connected layers and output layer in this particular half of our VGG 16. So technically, the first half is responsible for extracting the features, and the second half, that is here, is responsible for interpreting these extracted features. So with the idea of transfer learning, it is possible that we can add new convolution and pooling layers to expand upon the feature extraction capability of the model, or we can add new fully connected layers in order to learn how to interpret the extracted feature on a new data set. Or of course, we can use a combination of both. So in this example, what we will do is actually remove this classification part of our VGG 16 model and insert a new set of fully connected layers here. The other portion, that is the first half, which is the feature extraction, remains the same, but we are only removing the classification part and adding new layers for performing the classification operation. So for this, as you can see, I have loaded my VGG 16 model, and by having include top is equal to false argument, I am saying that I don't require the classifier part of my VGG16. I'm only interested in the feature extraction part of my VGG16. And then I can also specify the preferred shape of the image in our new data set. So which in this case I have used as 300 cross 300 cross 3. And here, as you can see, now I am adding my new classifier layer. So while I was loading my VGG16, I have not included the actual classifier part of my VGG16 model. So instead what I am doing is adding new classifier layer according to my need. So here, as you can see, I have flattened my model and then it is fed into a fully connected layer with just 1024 neurons, and immediately that is connected to a output layer with just 10 neurons. So we know that in the VGG16, original VGG16 architecture, this is not the classification part, right? So here I am adding my own classification layer to my already existing feature extraction part of my VGG16 model. So if I actually use this in order to train a new data set, in that case the weight of the VGG16 model and the weight of the new model, that is this one I have recently added, will be trained together on my new data set. Now in this particular example I am not doing any training, but we can always use this portion in order to train an entirely new data set. So let us go ahead and run this code. So when I run this code, since I have only asked to print the summary, I will get the summary of my new model. So as we know that till this particular portion, that is my feature extraction part is the same as that of my VGG16, but this portion is something exclusively I have added by removing the already existing classification part of my VGG16. So all these things are possible by using this concept of transfer learning.